Our last unit of the year, we're going to be studying what are called quadratic functions, which is a function with a power of 2. When you square x, you end up with a quadratic function. The first type of quadratic function we're going to be looking at is vertex form. As we saw yesterday, quadratic functions have a vertex or a turning point. Vertex form is when you can see the vertex right in the equation. So that h value gives us the x-coordinate of the vertex, and k gives us the y-coordinate of the vertex. We've already seen x-intercepts and y-intercepts with lines. We're also going to see them with our quadratic functions. An x-intercept is where the graph crosses the x-axis when our y value is 0. A y-intercept is where the graph crosses the y-axis when we have an x value of 0. And finally, we will be revisiting domain and range of a function. Domain are the input or the x values that can go into the function, and range are the y values that we get out of the function. Our essential question today is, how do we interpret the graph of a quadratic function? We're going to be analyzing our graph and determining several different pieces of information about the graph. The first graph we're going to look at is what's called the parent function of quadratic functions, because it's the most basic graph of a quadratic function that there is. It's just simply x squared. We're going to graph this on Desmos, and we'll put a little sketch in our notes, and then we'll identify all of this essential information about our graph. Here's the graph of our x squared function. Some of the information that we will need are x-intercept and our y-intercept, where the graph crosses the x-axis and the y-axis. For our parent function, the x-intercept and the y-intercept are the same. When you substitute 0 in for x, you get 0 for y. So starting off with our sketch. Again, it does not have to be perfect, but we do need to identify some of this information. So there's our x-intercept, y-intercept, as well as the turning point of our function. So all three of those are the same point on this graph. So finally, let's talk about domain and range. Domain is what values can we put into the function for x. Well, you can square any number, so the domain is all real numbers. The range is what values do we get out for y. Looking at this graph, notice that our graph does not go below the x-axis. That turning point, the vertex, is where we identify the range of the function. Our graph opens up, so our y values are greater than or equal to the y-coordinate of our vertex. Next, let's look at a transformation in vertex form. So we can identify the vertex from our equation. Remember, this is in the asylum, so it's not normal. Instead of a -2, it will be a +2. Here's the y-coordinate of our vertex. It's outside the asylum, so it is normal, so it will be 4. We'll check that answer with our graph once we get that sketched. Here's the sketch of our equation on Desmos. Notice where the vertex is, 2, 4, exactly where we identified that it should be. Our graph opens up. It has that positive leading coefficient. I changed the window on this because we will also need to know what our y-intercept is, so we have that identified for us as well. Creating a quick sketch of our graph, identifying some of those key points. And then we will get the rest of the information we need. Desmos identified for us that y-intercept of 0, 12. For our x-intercepts, we are looking for where the graph crosses the x-axis. In our case, the vertex is above the x-axis and the graph opens up. Our graph never crosses the x-axis, so we have no x-intercepts. Domain for quadratic functions, you can square all real numbers. So for every quadratic function, our domain will be all real numbers. Range, again, comes from the y-coordinate of the vertex. Our graph is opening up, so our y values are greater than or equal to the y-coordinate of our vertex. For our last equation, let's try and identify that vertex, and then we'll check with the graph and see if we were correct. The x-coordinate of the vertex is inside the parentheses grouped with the x, and it's opposite, it's not normal. The y-coordinate is outside the parentheses, and it is normal. Taking a look at our graph, let's zoom in on that vertex. -2, 1 is what we got when we looked at the equation. Here are our two x-intercepts, and on the y-axis, we find our y-intercept. Creating a quick sketch of that graph. Labeling those key points, we had a y-intercept of -11, our vertex -2, 1, and those x-intercepts weren't real nice. We'll just list them down below here where we're asked for that information. This time we had two x-intercepts. There were two places our graph crossed the y-axis. With a parabola, because it has a turning point, that can happen. And we've now seen the three different types of graphs for quadratic functions. The first one had one x-intercept because the vertex was on the x-axis. The second had 0 x-intercepts. The vertex was off the x-axis and it opened up. The vertex could also be below the x-axis and the graph opens down to have 0 x-intercepts. And finally, and this is the most common one, quadratic functions can have two x-intercepts. The first one was -2.577. I didn't leave myself enough room to write all of that, so I did -2.6. The second one was -1.423, so I will write -1.4 rounding to the nearest 10. Our y-intercept we identified on the graph, 0, -11. Domain, for every quadratic function, you can always square every number, all real numbers. And that range we get from the y-coordinate of the vertex. This time our graph opens down, so y is less than or equal to 1, the y-coordinate of our vertex. You have one U-try question, graph it on Desmos, and identify that key information about the graph.